Hello guys, welcome to Ramta Solutions and welcome to your lesson on vertical projectile motion in one dimension. So today we are summarizing the graphs that we had. Okay, we are summarizing the graphs that we dealt with. So to summarize, we're going to have a reminder rather. We're going to summarize them according to cases. Okay, so let me remind you that our graphs for velocity versus time, we had vf equals vi plus a delta t, which looked like a straight line. And for position versus time, we had delta y equals vi delta t plus half a delta t squared, right? And we also said this guy looks like he is y equals c plus mx, while this guy was y equals bx plus ax squared, right? I put quotes on y and a to say these are not the same things. Okay, so we said they are like that. Now we then had for velocity versus time, we had about 4 cases. For position versus time, I reduced them to 4. With acceleration versus time, okay, that one, because it's just a line, it's a constant, I'm not going to touch it. Okay, so I also mentioned that when an object is thrown upwards, you will have what we call time symmetry, which says time to reach maximum height is equal to time to return to initial position, right? So let's try to summarize our graphs. So one, I'm going to look at one object being thrown, object being dropped. Okay, let me look at object being dropped. Okay, when an object is dropped, I will try to look at the graphs. Let me see how I can look at them. Okay, I will try velocity versus time. And I will try position versus time on the right. Okay, I will try position versus time on the right. So when an object is dropped, we had a graph like this, and we also had a graph like this, right? Velocity. Do you guys remember? Our graph was like that. This was when a was this was when an object was, when upwards was positive. This is when downwards was positive. Now the position versus time for this part here was, we need to be careful. It was, let's see, when downwards was positive, it was like this. When upwards was positive, it was like this, right? When upwards was positive, it was like this, right? So and then again on these ones here, on the thingy, on the position versus time, this was when initial point was reference. Now when the ground was a reference, this guy looked like this. Okay, let me put y t y t. Right, so it was something like this. Right, it was something like this. Right, so y t. Right, and this one here, oh sorry, it was this one here was like this. It was like this. Right, it was like this. Right, so let me try to draw a line here, as well. So this one here, for the both of them, this is when a reference was point of release. Right, this was when a reference was point of release. This one here, this was when reference was the ground. Right, as you can see from the top of the building or the top of the hill, this is the ground. This is the top of the hill, this is the ground. Right, so these are our graphs. So the left hand side is when upwards is positive, the right hand side is when downwards is positive. Similarly on position versus time. Okay, so this is how we look at them. Again, remember I said to you, area under velocity versus time, will give you position or displacement. Right, area under velocity versus time will give you position or displacement. As you can see, this area here would rather this shape here represents a triangle. So if you are asked the distance that the object traveled or the height of the object, you can simply use area of the shape here, or you use your equations of motion, noting this is initial velocity, this is final, and this is time. All right, so this is how you will be doing it. Okay, all right. Now let's look at when I'm gonna call it case 2. Okay, I'm gonna call it case 2. This is when object is thrown upwards and returns to initial position. Right, so with this one, let's look at velocity versus time. Okay, let's look at velocity versus time, and then look at position versus time. So let me try to separate them as well. So this one here, yeah, let me try to separate them as well. So this one here would be upwards, when upwards is chosen to be positive. Remember, we had what we call time symmetry, T1, T2. And here we have also this, which is T1 and T2. So T-axis, V-axis. Alright, so this was when upwards was chosen to be positive. This is when downwards was chosen to be positive. Now, when the ground, when reference here, let me say when reference is point of release. When the reference is point of release, our graph looked like this. When it was point of release, it was it's supposed to be frowning. So it was gonna be like this, right? Y0 delta t, and this one here was smiling, so it was like this, t y0, right? Now when the reference point was the ground, when the reference point was the ground, because we said upwards is positive, it was a bit up there, right? And this was the y-intercept. The y-intercept was the point above the ground, right? Now for when downwards was positive, because being going upwards was was considered negative, because you said your positive direction is the downwards direction. Your graph, when downwards is chosen to be positive, your graph will look like this. It's a smiling parabola. So this is your y-intercept. It's in the negative axis. Okay, so this is how your graphs look like. Okay, this is how your graphs look like when an object is thrown upwards and returns, right? I hope you guys can see that. So look at it. Look at maximum height. Check, this is maximum height. This is maximum height. Okay, this is maximum height, and this is maximum height. In the same manner, maximum height is here, and then this one here is maximum height. So this is the time to reach maximum height. Now remember time symmetry. Time to reach maximum height from point of release is equal to time to return to point of release from maximum height, right? So basically we're saying this half is equal to this half. Okay, you still remember your axis of symmetry in your parabolas, right? All right, guys. Now this is the time to return to initial position. Now case 3, object is thrown upwards, returns, passes point of release, and hits the ground. Okay, now again, we will have velocity versus time, and then we will have position versus time. I don't know why I like writing this position in full. Okay, so here we are. Now when upwards is chosen to be positive, okay, it's not a nice straight line. Let me make it a nice straight line. Nice. Yeah, I think it's nice now. So this is velocity, this is time. Now let me try with this one here. Yeah, so okay, so when an object is thrown upwards, returns, and then returns, passes point of release, and then hits the ground. The point where the object is going down will be longer than the part where the object is going up. right? So this is your initial velocity, which is the velocity with which the object was thrown, right? The velocity with which the object was thrown. Now let's look at the position versus time. I'll begin with your reference being, I will begin with your reference being point of release. I'm saying point of release because I want you to consider whatever point, as long as you are above the ground. So it'll look like, okay, go back to white. It'll look like this, okay? And then this one here will look like, it'll look like, okay, notable. So this one here will look like this, okay? T, Y, T, Y, 0, 0, okay? So this is your position versus time when your reference point is point of release. As you can see, this is the time at which you release the object. This is the time at which the object reached maximum height, the time at which it returned to the initial position, and the time at which it hit the ground. Now, let's try reference point being the ground. When the reference point is the ground, oh, y-axis, and 0, 0, it'll be like this. It'll be like this, okay? So these are your graphs, okay? These are your graphs, okay? Now, I also want to mention that here you will be asked to find, you need to understand the difference between position and displacement, distance and displacement, right? You need to understand the difference between distance and displacement. When they ask you what is the distance traveled, distance, remember, is the sum or the total length of the path taken. So you'll be saying the area under this part here plus the area under this part here. But when they say what is displacement, when they ask you what is displacement, you can basically say it's one plus the other, but taking into consideration their signs. I remember when we deal with displacement, we always say it is, when we deal with displacement, we always say it is final minus initial, right? We always say it is final minus initial. So you need to get the difference. But otherwise, from your graph, you can get that information. Again, from your graph, you can get the values that you need to substitute into. You can get the values that you need to substitute into your equations of motion, whichever graph you can think of, whether it's a position versus time or it's a velocity versus time. All the information you need is derived on the graph. You can substitute it into your equation of motion and get your answer. Okay, guys, so this is the summary that I needed you guys to have with regard to the graphs. I believe before you watch this one, you have watched the full videos on velocity versus time and position versus time. This is just a summary to show you how the graphs look like, right? So while we are on this one, remember I said on the part where the object is going down, the arm will be longer than the part where the object is going up. As you can see here, it is also the same. Can you guys see that? It is also the same. So this one extends after point of release, extends to the ground. Can you guys see that? All right. So with that being said, guys, see you next time. Our next video will be on, I believe it'll be on chemical equilibrium. Okay, see you guys. Bye bye.